Hello everyone and welcome to the TCT Women in 3D Printing Innovator Award Day hosted by TCT Awards and TIPE. I'm Laura Griffiths, TCT's Head of Content, and I'm very excited today to be hosting today's celebration of Women in 3D Printing and the 5th year of the TCT Women in 3D Printing Innovator Award. I'd like to firstly introduce you all to Women in 3D Printing founder Nora Touré, who joins me today to welcome you all to today's event. So, hi Nora.
Hi, Laura. Thanks for having me and thanks for having us. Thank you so much again for this opportunity of having both the TCT Women in 3D Printing Innovator Award combined with TIPE this year. This is the first time doing it all together, and I couldn't dream of a better platform for having TIPE. For those of you who may not be familiar with TIPE, it stands for Technology, Innovation, Industry Application, People, and Economics. And it is the annual conference for women in 3D printing. So as I said, I couldn't dream of a better platform for us to have this joint event today. And excited to hear from the 4 amazing speakers we have coming up. And I think, Laura, you have the program in store for us.
I do, yes. And likewise, Nora, I'm so happy to be working with you again on this because you and I have worked together now for many, many years. But this award and today really feels like the culmination of all of that. You know, it's a collaboration between TCT Women in 3D Printing, TIPE, and the awards. And our collaboration on the award specifically was established back in 2019 to really highlight the work being done by women inventors, researchers, adopters, advocates in additive manufacturing. So I think this year we really wanted to do something a little bit different to honor all of our previous winners and the themes of the TIPE conference. So today we've brought together all of our 4 previous award recipients to share their AM expertise, and we're doing so within the framework of the TIPE 3D printing conference themes. You're going to hear from Yeong, Professor and Chair at the School of Mechanical and Aerospace Engineering at the Nanyang Technological University, Singapore, Eliana Fu, Business Development Manager for Aerospace at TRUMPF, Alba Gonzalez Alvarez, CEO and founder at Xcure Surgical, and Brigitte de Vet, CEO at Materialize. So an amazing lineup of speakers and such a vast array of AM knowledge. So then we're going to be bringing together all of our 5 finalists for this year's award in a panel session where I'll be putting some questions to them, and you can hear all about their amazing work in the industry. And then after that, the public vote will be open for you to vote for this year's winner. I'd like to just say some thank yous before we get into it. I want to say thank you to the TCT Women in 3D Printing Award sponsor, EOS, and to TIPE and Women in 3D Printing sponsors, Bamboo Lab, Nikon Advanced Manufacturing, and SME. And also an important shout out to 2 people who aren't on the screen with Nora and I today, but have been working away behind the scenes to bring all of this together. So that's Amanda Hull, TCT Special Projects Manager, and Lisa Block, Women in 3D Printing Board Director. I'm sure you'll all leave today's event feeling really energized about the AM industry. So I think, Nora, let's get into it.
Absolutely. Let's do this.
We'll be back in a moment with our first speaker, Yeong. Our first speaker today is Yeong, Professor and Chair at the School of Mechanical and Aerospace Engineering at the Nanyang Technological University, Singapore. Yi was our very first recipient of the TCT Women in 3D Printing Innovator Award back in 2019 now, awarded for 2 decades of contributions to the fields of 3D bioprinting, electronics printing, and metal printing research. Fundamentally, though, Yi really recognises the importance of people in these academic areas and this idea of communityship in shaping science and technology development. So very much touching on our TIPE themes today of people and technology. So it is my pleasure to welcome Yi for our very first presentation of the day.
Thank you very much. Very happy to be here. I'm Yi from NTU. It's my pleasure today to share with you a little bit more on the technology trends on 3D printing and bioprinting for the future of health. A bit about myself. I'm from NTU Singapore. I'm also affiliated to the Singapore Centre for 3D Printing, which recently has been recognized as the best academic and research teams by 3D printing industry. And for my research, most of my research centered around 3D printing and bioprinting. I published a few of these textbooks, and I've also served as the associate editor and editor-in-chief for some of these journals centered around bioprinting, 3D printing, and AI for materials and design. Now, on 3D printings, we are all very familiar about the current advancements and development of 3D printing, where it's been applied to create many new biomedical solutions, including biomodels, medical devices, hearing aids, mold for dentistry. There are also implants which go into more critical applications, like solid load-bearing implants made of plastic or metals with a lattice structure that can encourage bone ingrowth compared to normal metal implants. And there are also current research work ongoing and some successful commercialization example about degradable implants that will match with the tissue ingrowth and repair of tissue. But with the advancement of materials and systems nowadays, 3D printing gives us a lot more power to manipulate and process more and more biological relevant material. And that gives rise to the field of bioprinting with the potential to create mini organs and engineered tissues. Now, if you look at 3D printing, we know that it is layer by layer and we create the fundamental unit, we call it voxels, and using different techniques, we assemble voxel into a 3D part. The interesting thing in bioprinting is that the voxels are not just fixed shaped. The voxels are actually material combined with living cells, and we fabricate it into fundamental block of droplets or strands of cell hydrogel. And with that, we are creating droplets and hydrogel to become voxels that come alive because the voxel continue to remodel, continue to grow into a living construct that we want to create at the end. So if we look at this figure, we can see that the meso level building blocks is what we get from the printer, but very much important is that we have to design a living environment for the cells. So the actual living voxels are actually embedded inside the material that will serve as the 3D environment for the cells to continue to grow and proliferate and grow into the final function that we want. And when we have all this assembling of living voxels into the macro shape, mimicking the anatomical shape, we're actually looking at the potential of creating anatomical models, anatomical organs that we can use for further applications. Very key is we have to consider the printability of material, the resolution of material, and also where the cells are inside that niche environment within the 3D voxels. We have used jetting techniques to create tissue models for soft tissues such as photoreceptor and retina, which is at the back of the eye, which we show that by using 3D bioprinting, we're able to split a big droplet into very small, tiny droplet, and that gives rise to a more homogeneous single layer and also give rise to a better connection between the cells so that the cells can communicate better in a biomimetic design that we can follow with the natural design of the human organ. For example, in this case, we are following the design of a photoreceptor which have the cone cells and also the rod cell distributions. Similar concept is the 3-layer human alveolar lungs model. So essentially is the endpoint of the lung that take care of the exchange of gas. So it makes of 3 different types of tissue that have to be living together and function together in order to form into the final blood-air barrier functions in the alveolar tissue models. So using jetting 3D bioprinting techniques, again, we successfully fabricated a triple-layer tissue model that made of 3 different types of human lung cells, including epithelial, endothelial, and also fibroblasts. Now, beyond just using bioprinting as a tool to assemble these 3D living voxels, we're using bioprinting as a design tool. As we know that for human organ is the best machine. It contains a lot of features that are closely related to the function. So in order to achieve the function, we need to follow the kind of natural design that are already happening in our tissue and human body. So in this case, skin is actually a very thin layer that have absolutely good barrier functions to protect the humans with a different porosity of the skin tissue across the thickness. So in this case, within the design zones of 100 micron, 150 microns, it is very challenging for us to use 3D printing to achieve the kind of resolution that allow us to mimic the natural design. So in this case, we use 3D bioprinting as a design tool and put in the material formulation that can help to tune the final porosity that we can get within the space of 150 micron. And from there, we're able to get very thin porosity at the bottom and very thick material, more dense material of a collagen fiber at the top for the skin to mimic the natural designs of a skin layer. We also use jetting to deposit the melanocytes, the pigment cells in specific locations so that we get homogeneous color for skin tissue models. Now, in terms of extrusion bioprinting, which we are able to deposit bioink with cells in a strand voxel shaped. In this case, we know that extrusions have shear stress. Right? The material have to go through from a larger cross surface area to a very small surface area of the tip of the print heads, and that change of a surface area plus the velocity that's experienced by the material actually creating a lot of shear stress inside the material. Generally, it is not good, but if we understand the impact of these shear stresses to the cells and able to capitalize on it, we actually can use it in combination with 3D bioprinting techniques to create very interesting effect. For example, in this case, we know that from biological fundamental studies, cells will react to fluid shear stress, right? Compared to without any fluid shear stress, the cell will grow in random directions. But with fluid shear stress, the cell will actually grow in a specific direction following the flow of the shear stress. And that gives us a way to achieve large-scale cell alignment if we can maintain and control the shear stress within the hydrogel inside the printer, and with the reactions of the cells living inside the material culture after a period of time, we're able to input the signals into the cell hydrogel to direct the cell to grow in a specific manner, specific direction, following the print path and also the print directions of the construct. And with this means that using 3D printing is not just giving us a way to achieve the 3D macro shape, but using the printing, we are able to impart the invisible effect, which is the shear stress, into the print path optimizations to achieve the angular position of muscle fiber plus the large format cell alignment. And with more research, we are hoping that one day we'll be able to mimic the cell alignment of a cardiac tissue or into an organ as large as a heart. It's also possible to develop new bioink with high printability so that we can get vascularizations to mimic the vasculature in humans' organs. So in this case, with macrochip plus the vasculature printing technique, then we are moving more and more into a more realistic tissue model that is made of different type of cell, different type of tissues. Now, with all these advancements, we are hoping that one day it's not just tissue models, right? The ultimate power of bioprinting, of tissue engineering is really go towards precision medicines, where we can develop personalized control, personalized diagnostic techniques, and personalized medical treatment to each of the patients. And in order to do that, just by material and good printing techniques alone is not enough. We need a lot more information. We need to understand more at the biology value, at the physiological level, and also at the system level. So right now, we are seeing a lot of applications of 3D printing for biomedical sensing devices, right? There are a lot of sensors in the eye, sensors on skin, lab on chips, wearables, a lot of all these very nice applications that is being realized and enabled by the freedom of design we get from 3D printing. But in order to go into more biological relevant zone of information gathering, then we are really looking at bioelectronics, where the sensor is not just situated outside of the system, but is integrated within the biological system. So bioelectronics is the next frontier. It is the area that deals with interfacing electrical circuits with biological species. With electrical stimulation, we have known so far that it can affect cell responses and it can activate intercellular cell signaling and pathway. And with a good way to embed the electronics within a biological system, it gives us a new way to engineer tissues and design new medical devices. The challenge now is, how do we design this bioelectronics interface which is functional, or the interface that will combine the soft part of it, which is the tissue, containing cell, containing electrolytes and all the physiological responses, and be interfaced directly with electronics, which is the integrated circuits within the same continuum, and is not embedded externally or forcefully into a soft tissue. So how do we establish this interface is actually our current research and our current target. We need to overcome the challenges such as mismatch of material stiffness when we try to combine a organic material with inorganic material. By slotting in external sensor, we might create scarring to the soft tissues. And at current stage, a lot of all these sensors and electronic circuits, they're actually very 2D, very high resolutions and very flat. Right? All this doesn't really gel very well with the organic design of human organs. So it is our goal that we see a new paradigm enabled by 3D bioprinting. 3D bioprinting of cells and tissue has already been demonstrated under active research. A lot of examples have been shown. But on the other hand, we also know there is this research in the space of 3D electronics printing. So printing of electronics in free form in different dimensions with the potential to design different type of material and medium to carry the functional particle, to carry the function of electronics. So this is a convergence of bioprinting and electronics printing that give us a new way to enable us to create bioelectronics tissues. Now, looking at electronics printing, we know that we can do 3D printing of sensors, of electronics components, of conductive tracks on any surface, any shape of the surface, using existing technique like aerosol jet printing. This is just a figure showing the working principles of aerosol jet printing that allow us to deposit very fine traces of conductive material, functional materials on surfaces. We have already used 3D printed electronics to demonstrate many different applications, like for example, pressure sensitive smart glove, bandage-based strain sensors. We also develop a flexible pH sensor that is by 3D printing for cell culture, showing that it is possible to interface printed electronics materials with living cells for cell monitoring purpose in the in vitro setting. Current latest development also see that there are more and more functional material in the electronic space for novel bio applications. For example, biocompatible and stretchable material for implantables. And there are also a good research ongoing now developing green material for sustainable electronics that are more biocompatible. So the goal is really, how do we put these two together, right? The bio biological materials with living conditions that is very sensitive to solvents, sensitive to heat. At the same time, we know that there are a lot of potential when we add in the digital part into a biological components. So at the prelim level, we investigated and developed a novel 3D bioprinted flexible hydrogel bioelectronic platform at the 2D space for now, which we are able to combine silver inks that is conductive, and depending on what kind of pattern that we have designed, we can make it into heated or a monitoring stimulating circuit to stimulate the cell growth by using current and voltage flow. So in this case, we've shown that it is possible to maintain the survivability of cells in very close proximities of silver ink. And this silver ink can take any shapes as we are building the voxels together alongside with bioprinting as we deposit the nanoparticle ink into the hydrogel with cells. So in this case, the hydrogel that we use is a Gelma, a kind of hydrogel very popular in bioprinting, very compatible with cell growth, it supports cell growth. And then in this case, you can see that the silver is very nicely embedded within hydrogel around it. And we can imagine the hydrogel will be the space where the cells will populate and grow and remodel as it's established the interface with the conductive material inside the hydrogel. Now, with the construct alone is not enough because we need a setup to bring the signals out from the bioelectronics tissues. So in this case, we also designed a platform that we can put the bioelectronics tissue on so that we can continue the measurement to inject signals into the bioelectronics tissue and also to extract signal from the bioelectronics tissue. And this is our new piece of work that is ongoing, which then leads us to the future potential with the ultimate goal, the ultimate vision that we are able to create a 3D bionic organ for tissue level information that is connected to a device, digital devices that allow us to stimulate the tissue at when it is needed to direct the tissue response, for example, to direct the cell alignment, to direct the activations of certain functions. At the same time, then this bionic organ with embedded sensor inside will also be able to pull and extract information out from the tissue at real time so that we understand what is happening inside the tissue and able to intervene when it is needed. For example, if the pH level is not at the right value, then we'll be able to perform subsequent actions in order to ensure that the growing environment of this organ is at optimum level. So with that potentials of bionic tissues, then we are looking at the ability to extract data directly and real time from wearables, from implantables, or bioelectronics tissue, and combining that will allow us to understand more, a lot more about the human body, about diseases, and that will serve as the basic database to enable better designs of a drug, better design of therapy. And that also gel well with the current goal of building a digital twins of humans. The goal is the same, that allow us to have a repertoire of data that we can cross-examine, cross-analyze, so that we understand the effect of drug at system levels when the drug is being designed at the individual levels. In this case, we can also apply the computational tool and allow us to do a lot more modeling and in silico simulations, which then directly will help us to reduce the needs of animal studies and give us better accuracy when predicting and understanding about human disease for diagnosis, for prognosis, and for therapy development. Now, when we talk about data, then we know that we need a lot of data, right? In this case, if we look at in terms of process modeling simulations from component level to system levels, if we make an analogy to say aeroplanes, we know that for biological system, it will only be much more complicated. And that leads us to the next trend of technology in 3D printing and bioprinting, which is about AI. Right, there are already a lot of application of AI in 3D printing as we speak now. You can use AI to support 3D printing in terms of design, in terms of material optimizations, in situ monitoring, and also post-printing analysis. In bioprinting, we also see a lot of papers explain about how they use machine learning to determine the printing process to enhance printing outcome. For example, to enhance the shape fidelity of soft material, to check printing quality during printing, and very importantly, to check the living voxels, right? The cells have to still be very well maintained, very lively, and can continue to grow inside the material after printing. So the cell viability is also a very key index and can be enhanced by using machine learning. Machine learning and AI also is being used to accelerate material discovery, right? By combining the synthesis conditions with AI to accelerate material science that will allow us to create new formulation without even the need to have prior knowledge for the primary formulation to fit to the final application that we want to design for. With all these data and printing technique and material, it is then point us towards creating a database for biofabrication, which some research groups are already starting to do that. And we can imagine that one day this database will be formulated with a lot of information that can accelerate the research around the world, so that different research groups, they can just plug value from the database and build on the knowledge that other research groups have already created. And we might even expect that LLM in 3D printing, large language model in 3D printing, they can help us to analyze textual data, can generate actionable insights by synthesizing all these different type of data sets, be it in 3D printing or 3D bioprinting. So in summary, the technology trends showing that functional 3D bioprinting and functional voxels embedded with digital materials present a holistic approach to achieve complex organ design. And with all these current trends of AI, we know that it's going to accelerate the research in 3D printing. And it is very important for us to incorporate new digital and computational technologies towards 3D bioprinting for the future of health. Thank you very much for your time.
Thank you, Yi. What a fascinating series of topics to kick off today's presentations with. I will absolutely be picking your brain for more on bioelectronics in the very near future, I'm sure of it. We'll have more medical insights in just a few moments with our next speaker, Alba Gonzalez Alvarez, so please stick around. And thank you again, Yi, for a great presentation.
Thank you.
Our next speaker is Alba Gonzalez Alvarez, CEO and founder of Xcure Surgical. Alba is a doctor in biomedical engineering and was our third winner of the award in 2023 for her work developing hundreds of implantable medical devices using 3D printing. Today, Alba has founded Xcure, a startup that develops and commercializes 3D printed patient-specific devices for complex bone reconstructions of the human body. It's a great topic for our industry segment, and I'm very excited to hear what Alba has to say about the next generation of these devices. So please welcome to the stage, Alba.
Thank you very much, Laura. Thank you for the introduction. Thank you to the TCT Group and the TIPE 3D Printing and the Women in 3D Printing for organizing this and inviting me to present. You have presented me very, very well. I founded last year Xcure Surgical, a Spanish startup developing 3D printed custom implants for complex bone reconstructions of the human body. And today I'm going to focus this presentation on, showing some of the clinical cases that we have worked on in the past to use 3D printing to help patients across the world have better lives and better health. No? I've been fortunate to develop a wide range of custom implants, including maxillofacial implants, orthopedics, thoracic devices, and spinal implants. You can see here a little summary. Each of these devices requires unique processes, specialized knowledge, and varying development timelines. And today I will walk you through the development of some of these designed for specific clinical patients. I'm going to present one device for each clinical specialty. And let's start with a custom maxillofacial device. Maxillofacial surgery is actually one of the medical specialties where 3D printing is most widely applied because, reconstructing the head and neck requires not only good functional outcomes, but also aesthetic precision and accuracy, and therefore 3D technology provides all these benefits. I'm going to start. So this clinical case focuses on an orbital floor reconstruction. So how do we go from identifying the problem based on the surgeon's diagnosis of a defect to the final implantation? This is a case, an orbital floor defect after an injury. This patient had an accident, and initially the zygomatic fracture was reduced immediately after the surgery. However, due to the large size of the defect, the reconstruction and the floor repair was postponed for a second surgery to allow for reconstruction with a custom-made implant. So we did a complete digital workflow for the reconstruction of this bone, including 3D CAD design and 3D printed. We designed a 2-piece plate so that each half could be inserted separately to reduce the incision length. We did manufacturing by the powder bed fusion technology of the implant in titanium alloy. We usually use titanium 6 aluminum vanadium, which is one of the most widely used materials to reconstruct bone in the human body. And we sterilized the implant. We used it in surgery, and it went really well. And patient is doing really well until date. This clinical case is published in the British Journal of Oral and Maxillofacial Surgery, and I invite you to read further to find out more about the development and the outcomes. I'm going to present now a custom thoracic device to reconstruct the chest wall of a patient. This was a 55-year-old patient that was diagnosed with a very large thoracic chondrosarcoma affecting the second, third, and fourth right-sided ribs. The tumor needed to be resected, and it was decided to be treated with a 3D printed titanium implant. We did a complete workflow of 3D digital planning and design and printing. We started with a 3D CAD design of the reconstruction, and we rapidly prototyped multiple designs using resin and the stereolithography technique to refine and define the final design, which it was manufactured in titanium 6 aluminum vanadium using powder bed fusion technology after an iterative testing and refinement process. Then again, the implant was sterilized and it was used in surgery, and it was a very successful surgery. It was one of the first thoracic implants designed for the chest wall. This was developed in 2018 at Moreston Hospital in the UK, and it was also published. So again, we invite you to read further. I'm going to present now a spinal implant. Specifically, I'm going to present a device to correct scoliosis in children. It is a growing rod for severe pediatric scoliosis. As you know, scoliosis is the abnormal curvature of the spine, and when it is diagnosed in children younger than 5 years of age, it's called early onset scoliosis. And when surgery is needed, we use growing rods. Growing rods are extendable devices that are implanted through the back of the patient and attached to the curvature of the spine. And the challenge is to correct the spinal deformity while allowing the growth of the patients over the years. So the treatment is that every 6 months, the implant expands and strengthens the curvature of the spine. We designed a growing rod that had a rack rod and pinion system for the elongation mechanism that allowed the device to be elongated in a minimally invasive way. And at the same time, we added a dynamic system to provide some flexibility to the construction to avoid mechanical complications of the implant during the years of treatment. The device was attached to the ribs in the upper part of the curvature of the spine by way of hooks, and it was attached to the vertebra of the spine in the lower part by way of screws. We did a complete mechanical characterization of the implant, performed mechanical testing to verify the fatigue resistance of the device, and here we have an image of the final implant. And again, the clinical case was also published in the Journal of Materials and Design, so you can read for further information. Well, with regards to custom orthopedics, which is one of the main specialties that we approach and we develop implants for at Xcure Surgical, I'm going to present 2 clinical cases, in this case for the pelvis. One case is going to be for oncology, and one case is going to be for a revision case of pelvic arthroplasty. So the first one is, in this case, to treat a pelvic tumor, a massive pelvic tumor in the right hemipelvis. We did a digital virtual planning of the surgery. We identified the resection margins of the tumor that we have identified and colored in red. And we designed a surgical guide that you can see in green at the right side of the slide, to guide the surgeon about where to perform the cut of the bone to remove the tumor and have clear resection margins. We did a complete analysis of the biomechanics of the pelvis to design this custom implant to reconstruct such large defect. As you can see, we did an analysis of the center of rotation, the inclination, anteversion of the cup, a complete biomechanical analysis. We added also some porous structures at the interface of the implant with the bone to promote some osseointegration that you can see in the image. And also we 3D printed the design again in powder bed fusion technology in titanium, 6 aluminum, and 4 vanadium. And to finish, this final case is a custom implant for revision hip arthroplasty. The patient had a primary hip replacement. It was inserted 15 years ago, and it began to fail over time. The implant had loosened, causing significant bone loss around it, and the bone defect was so extensive that we considered that the best option was to perform and to develop a custom-made implant. We did, again, a complete biomechanical characterization of the implant. We 3D printed it using biocompatible titanium. You can see there also a surgical tool to insert the implant intraoperatively. And we see there the devices developed in the operating room. And after sterilization, we can see also the post-operative image of the implant in situ and the patient walking 1 day after surgery. And here you can see that we have published several papers establishing the scientific evidence that supports the use of our 3D printed custom implants and validates the biomechanical design processes of various implants and their manufacturing through 3D printing. So I invite you also to read these publications to learn more. And thank you very much.
Thank you so much, Alba. It's great to hear how things are progressing so quickly with Xcure, and to hear all these examples over the years. It's just such a great reminder of the power of this technology. I will just ask you a couple of questions because we've got you for a few more minutes now. But I wanted to know, to start with, when we first spoke, when you took home the award in 2023, of course, Xcure Surgical wasn't a thing yet. Just tell me a little bit about what you wanted to do and sort of set out to do differently with founding this new company.
Well, that's a great question, and thank you for asking. Well, over the last years, I was very, very fortunate to work for other companies. I also worked in-house in hospitals, developing devices at the point of care. And as you know, I did a lot of research. I did a PhD in the UK. It's where we got first in contact in Birmingham, and then a postdoc. And so that experience gave me a very good understanding of the market of custom devices from the industry, from hospitals, and from academia. And I understood how difficult it is actually to bring this technology to patients and to make it scalable and to make it accessible for everyone. And basically, the best option for me was, in order to bring these innovations to patients, to found my own company and follow my vision to make 3D technology accessible to everyone. And actually, one of the keys at Xcure Surgical now is to build a strong platform where technology can be used for every patient that requires a custom implant, and also to certify these implants with and to make the channel from development to the surgery room optimal and more easy, because at the moment regulations and there are a lot of barriers. And I wanted to break those barriers, work on optimizing the processes and make them affordable for everybody.
And you mentioned then that there's lots of barriers, but when we got on this call today, I know you said you'd been in surgery already like twice this week. You're super busy, but this just shows like how real, and this is happening right now. This is impacting people's lives already today. I'm wondering, with those sorts of barriers, is it regulation that's the hardest part of getting this more widely adopted in the healthcare industry, or are there other things also in the way at the moment?
I think it's a combination of many issues. I think the world in general, hospitals are not really ready for exceptional things. You get to you get to sell a custom implant to a hospital, and if it's not within the standard devices that they usually use, trying to get it certified within the hospital is also a challenge. There are several barriers. First of all, this continues to be an innovative technology, whether we like it or not. Whether I have been doing this for almost 11, 12 years, but still it is an innovative technology. There are a lot of surgeons who don't know that they can use this technology. Prices are still a barrier. It is necessary to work on the development processes of these devices to make them more automated, so that we can reduce time for development, we can reduce cost. 3D printing needs to, as a technology, needs to get to a more, more standard procedure, standard technology, so that costs are also reduced, especially for metal printing. Metal printers are still, relatively expensive, and you need to use them a lot to make them affordable. And in general, certification as well is a thing for sure. It's a barrier, but also, it's necessary. You are doing devices that are replacing body parts for people. The process needs to be certified, and I understand that, but it is definitely a challenge. And the whole process requires a lot of investment. Innovation is always hard to push forward, but at the same time, when we are able to provide these devices to people, we actually make their lives definitely better, and we change people's lives. So that's the motivation at the end of the process.
I think that's such a great note to end on there. And I think you made such a good point that, we kind of forget this is still a very innovative, very new technology for so many people. And maybe when we're so deep in it all the time, we actually forget that it's not the standard way of doing things. There's a lot of learning that still needs to happen in wider industry. So thank you so much today, Alba. That was such an interesting presentation, and I can't wait to see what you do next.
Thank you very much, Laura. Thank you to the TCT Group, the TIPE, and the Women in 3D Printing community for organizing this. And, a pleasure to collaborate with you anytime.
Thanks so much. We're back again in a moment with our next presentation. Our next speaker is Eliana Fu. Eliana was the second recipient of the TCT Women in 3D Printing Innovator Award back in 2022. So we'd had a bit of a gap between our first award and the second. So I'm very excited to be here with Eliana today. Eliana has 20 years of experience in aerospace and metallurgy, and currently serves as business development manager for aerospace at TRUMPF. I will let Eliana do a full introduction to herself in a moment, but as you'll see from her bio shortly, Eliana's advocacy for not only advanced manufacturing, but also really the people behind them, whether that's as an ambassador for Women in 3D Printing or as an SME committee member, really made her the perfect choice today to be the representative for TIPE's 3D Printing Days People Track. So Eliana, welcome, and please take it away.
Thank you so much, Laura, and it is great to see you. So I'm going to talk today about the benefits of an intentional culture. And so we're going to enjoy the next couple of 15 minutes together, just talking on this very important topic, which I think maybe is a little bit under-addressed in this world where we're pretty much focused on the economy. So just a little bit of background about me. Yes, I am a material scientist with over 20 years experience in the aerospace industry, but also dabbled in primary metals manufacturing and metallurgy. My specialization is titanium, with also 3D printing and additive manufacturing, maybe in the last 8 to 10 years. And on the 3D printing and additive side, I've been fortunate enough to serve as a committee member for both SME and ASTM F42. When I lived in Los Angeles, California, I was lucky enough to be co-ambassador with my good friend Lindsay Zindrowski for Women in 3D Printing. That's a nonprofit advocacy group, obviously. And in 2022, I was fortunate enough to be named the winner of the TCT Women in 3D Printing Tech Innovator Award, something which I'm very grateful and proud to have received. In other advocacy work that I've done for volunteerism, I've also led the Asian and Pacific Islander Working Group, which is part of the DEI committee of TMS. TMS is the Minerals, Materials and Metals Society. And recently I've been working as industry manager for aerospace and medical at TRUMPF. I've had that position since 2020. And just this January the 1st, I've changed jobs to become business development manager for aerospace at TRUMPF. So talking about this tough economy and how employees see themselves in the workplace, I just wanted to set the scene for, people have reached out to me over the years asking me for literally job advice, as if I was the perfect person to give job advice. But these are my perceptions, they could be right or wrong, of what, kind of employers are out there and what kind of culture really these guys have. So, for example, large companies that could be anywhere from 5,000 to 50,000 people. You would expect that large companies would have established processes and procedures. When you're hired in, you typically have a position that has an established level and salary ranges within those levels. That the job descriptions that are posted are very well written out and meticulous. And you also, as an employee, will have an expectation that the benefits will be good. So those are things like 401ks, healthcare, time off, etc., that you expect them to be good, and that those things are negotiated with bargaining units, basically unions, where they're appropriate. And that culture could have been created in that company for maybe 100 years or more. So a good example would be something like the Disney Corporation, of thousands of people. It's over 100 years old. And my own employer, TRUMPF, is over 100 years old and also has thousands of people. Medium-sized company. So this could be something that is flexible, but with established processes and procedures. And you could be hired in to positions that potentially have overlap levels and also extending to salary ranges. So there could be some gray areas. That could be a good or a bad thing. If it's something that's good for you, that means that you are flexible and you maybe be able to push the boundaries of what's possible. And as a result, maybe a posted job description could slightly change. You also have an expectation that the benefits like 401ks, time off, healthcare, and so on are pretty good overall. But the culture might still be being crafted at that time. And then smaller companies, of which I've had a lot of experience lately in my career, are typically that could be anything as from 100 people down to like 5 people, or somebody starting a business out of their garage or their spare bedroom. In that case, you would expect the processes and procedures are not established at all. Salary ranges and job titles could be all over the place, and they can be negotiated. So it's every man for himself or themselves. And when you might find yourself interviewing for a job description and halfway through the interview, it changes. That's happened to me. You can expect that your benefits like 401k and healthcare might not be so good, but then you might be able to negotiate things like additional days off. You might be able to negotiate 4 or 6 weeks off, or flexible working, or anything like that. So there is no culture. You're just making it up as you go along. So let's take some examples of some companies which are considered great cultures. And now I've never worked at any of these companies, so I don't really know if they are, but this was the perception of them at the time. So something like a Patagonia, which I think in 2021 was voted on the top 10 best companies in the US to work for. And the phrase was that Patagonia values work-life balance, employee engagement, and a positive company culture. So that's the kind of thing that you want to see, especially with companies that's associated with the outdoor life and sustainability and all that sort of stuff, versus more of a manufacturing company like 3M or a tech company like a Google, where those companies also have a degree of innovation built in to the culture. So from 3M, there's something called the Friday afternoon playtime, where engineers can work on any project that they wanted to and just let their imagination run wild. And that's how Post-it notes were invented. Or at Google, where engineers can expect that they can work up to 20% of outside of their normal job on any project that they like. And that's how Gmail was invented. So basically, any cultures which seem to engage or incite or encourage employees to innovate or think outside the box, those seem to be attractive to work for. On the opposite side, we have a terrible culture. So what's a terrible culture? Terrible culture is a place where people ignore you, they don't listen to you, they're completely indifferent. You have a huge amount of bureaucracy. This typically happens with larger companies. It's just the way it is. And then sometimes even leading to stagnation. And in the worst case scenario, absolutely worst case, would be a culture where bullying and harassment is allowed to take place. And that's really not what we want. So typically a terrible culture can be anything from where you're ignored to where you're outright mistreated. So cultures where employees are put into rigid boxes, you know, people can't step outside the lines, they're afraid to speak out, they're basically missing out on opportunities. And you want to be making sure that as an employee, you're not choosing that kind of place to be. And the even more telling is that broken culture actually affects mental health. And I was interested, because I'm watching the Australian Open tennis at the moment, that even one of the top 10 tennis players in the world admitted that he suffers from depression and bad mental health. That is terrible. So it affects everybody. Mental health is a topic that affects everybody on any spectrum, no matter how rich or poor they are. It's a real problem now. And according to McKinsey, employee disengagement and attrition when people have bad mental health can cost a median-sized S&P 500 company somewhere between $228 million and $355 million per year in lost productivity. And according to this Gallup poll, when people rated their mental health as fair or poor, that actually resulted in lost working days of something like 11.8 lost working days per year. And that is pretty terrible, because actually it also has an effect on a company's economic status, bottom line, which nobody likes. So as we mentioned, there are employment challenges in this tough economy. You know, there are things where you could be having a company where there are key people where if they actually leave the company's at risk. So that's called key person risk. And attrition, people just leaving. So if you have skill sets that are difficult to backfill, that's a problem. There's also a phenomenon called quiet quitting. That is where people just get fed up and they leave without telling you why. And that is also a problem because it masks issues, prevents solutions, and risks recurrence. So as an employer, you have no way to stop that happening or even find out why it's happening. Other employee challenges are things like low morale, where people feel devalued and underappreciated. The demotivation actually risks industrial accidents and defects, and no one wants that to happen. But the lack of opportunity, or where they see no visible pathway for growth, that results in a downward spiral. They feel disconnected from the business strategy when they have little or no understanding of the importance of their work. And so they're not invested in their future. And then that leads to a transactional workforce where people just simply show up to take a paycheck. And it is impossible to perform to the best of your ability, and that leads to stagnation. So we have this phrase, which we all know, but nobody seems to do anything about, is that people don't leave bad jobs, they leave bad managers. But, you know, what do you do about that? So I like the idea of having an intentional culture, but what is intentionality or being intentional? So something that we can all relate to is if you do a yoga class, you go to a yoga practice and your instructor tells you to approach the class by being intentional. What does that mean? So setting up your intentions. What am I going to get out of this time that I'm in this class? Well, first of all, my intention is just to show up, because showing up to class means that you beat everyone else who didn't come to the class. And what it means to be present in the class, be active, focused on things like your breath, or focused on, I'm going to do a better downward dog than I did yesterday, and paying attention. So in the workplace, being intentional can be representative of goal setting, planning your behavior, ensuring that your actions are aligned with your intentions. So for an intentional culture, we can establish some principles. Let's say if you're starting a new company and you want an intentional culture going on, what do those actually mean? What are the core principles? And that could be something like to treat every employee with dignity and respect, or have a commitment to professionalism, ethics, and inclusion. And creating that intentional culture creates a cohesive environment where everyone's role has a value and meaning and is aligned with the company goals. And HR should be in lockstep. I know people always cringe when they think about HR because they think it's there to protect the company, but HR is just really the mechanism in which policies for things like code of conduct or conflict resolution can be addressed. Create progression plans for every role, performance planning for individuals, and reviews. And for that, you also need open communication. So whether that's in the form of regular all hands meetings or town halls, having an open door policy, come and talk to me, anonymous employee surveys if you don't want to see someone face to face, but having regular one-on-ones. And to build a learning environment where you encourage that atmosphere of learning to provoke creativity and innovation, to drive success and have a feeling of accomplishment. And so you need those guardrails in place to help the team succeed. So that every role has a meaning and every task has a value. You're not just doing busy work. And the managers have a responsibility to make sure that all of this occurs. Most of the time, they are making sure that the company meets its goals. But don't risk alienation by being closed-minded about it. And this can be done by being intentional. And employees, you also have a responsibility, not just to the company, but to yourself. All the tasks that you need to do, but also what are you going to get out of the time that you spend at that company, whether it's 5 years, 10 years, 15 years, or maybe just even an internship. So intentionality is the key driver to success. And I just want to leave you with a slide that I was in, which shows a snapshot in time a couple of years ago before the pandemic, in which I was part of an intentional culture. This ironically was a 3D printing company, but it was an environment where at that time, the employees felt invested rather than merely transactional. And a place where you see yourself growing professionally and technically is a company that has an identity with an intentional culture. And, you know, if you can base that on dignity, collaboration, and cooperation, that's all good. And by building an intentional culture, any company can be set up for success. So for that, thank you so much for your attention. And Laura, I will take any questions.
Thank you so much, Eliana. That was give us so much to think about there, both as someone turning up to work perspective, but also, you know, lots to learn there for employees too, and organizations to take away from. I do have some questions that I want to ask you because, you know, we're coming at this today from a women in 3D printing angle. So I want to kind of touch on some of the things you referenced there from a bit of a 3D printing perspective. You know, it's been a challenging time really for the additive manufacturing space over the last few years. We've seen lots of mergers and consolidation closures, so lots of uncertainty being felt. And, you know, while companies really deal with those challenges, what would you perhaps say to some who maybe don't see this intentional approach as a priority right now while they're dealing with these other sorts of things in the way?
Yeah, that's a really good question. And I feel like so I'm a big proponent of the technology. I love the technology. I think it's great. And it's proved that it's no longer a gimmick. It's here to stay. And it is an established manufacturing process, albeit some of the standards are still being written as we speak. Mm-hmm. And what is preventing, I guess, people from creating an intentional culture is mixed messages, or where people aren't clear of what the goals are. So let's say you have a 3D printing company and my goal is to innovate in 3D print. I know, I'm going to say 3D printing shoes. So if I have a company that's 3D printing shoes, what should my message be? What should my intention of my company be? It is to make 3D printed shoes as easy to access for customers, or is it to make 3D printed shoes that are tailored to individual customers, or is it to design 3D printed shoes in the most innovative way possible, or is it to encourage different materials to be used? So whatever those things are, those should be your guiding principles of how your company is going to be successful. Because once you've defined that and you work to it, that is going to provide you success, rather than the opposite of using 3D printing as a cash cow to go to the stock exchange. And we've seen a couple of examples of people who have done that and they've flopped hard, and it's been disastrous for them. And I feel bad for them, but in a way, they never had their intentions or their principles set up. Or if they did, they didn't announce it to us, and we don't know. Yeah. But I feel like if you know what that is, and you say, okay, these are my 4 guiding principles or my 4 tenets, and this is what I'm going to be good at, and this is what I'm going to focus my energy to do, you will be successful, right? So that's my personal feeling on it.
You've already touched on there, and another thing I've been thinking about that I wanted to ask you, and it was really, you describe the difference, or at least the perceptions between small, medium, large companies earlier on. And I wondered if you've just said there's lots of things companies can think about, and, you know, these are the steps that you need to take to be intentional. But are there any kind of immediate actionable steps that you think can be taken by organizations to really start that intentional journey right now?
Yeah, and that's a tough question, especially for the bigger companies, where they need to take a look at themselves, but they find it hard to implement because they've got shareholders, or they have thousands of people holding their shares who are on a stock exchange. It's way more difficult to do that. It seems to be easier in a small to medium-sized enterprise, or if you're one person, you can set your intentions. You can have a one-woman show. I could start a business out of my spare room if I wanted to. Yeah. But I need to be intentional, and then that will set the path forward. How can they get started right away? Is by making sure that roles and tasks, even individual small tasks, have value, that you're not just doing work for the sake of doing work, because that's meaningless. So even in a big company, you as a manager, you could think about, how do I approach this person's task or this person's job and make it meaningful, even if it's the simplistic job or whatever it is. Let's say you're just shipping and receiving. That's a vitally important role. People might not think that it's like a very glamorous role, but there are things that a shipping and receiving person could do which are intentional. Don't waste time. Think about better ways to move things from A to B. Think about ways in which you can save your back, or don't pick up large, or think about, are there better handling methods or things like that, or better drop-off or communication methods with your transportation services? So in any position, whatever it is, no matter how big or small or fancy or unfancy, there's a way that you can be intentional to make yourself a little bit more focused and make it more meaningful and less wasteful. You don't want to waste your energy. You don't want to waste your time. You want to get it done, and you want to get it done well, right? And then, if you're the accounting type, you can kind of put KPIs around that. You can put things like statistics. How long does it take for me to offload this laser to my customer? What kind of things do I need to have in place? Is there a checklist? And so streamline your efforts so that you make things less uncomfortable for yourself.
Okay. I do just want to try and squeeze in one more question before I let you go. I want to get your thoughts on the fact that we've seen a lot of companies recently reversing their attitudes towards things like employee inflexibility. You only have to look at the amount of companies that march people back into the office this January, and also even some just, really just doing away with DEI initiatives. And I wonder if you think there is a risk that we kind of revert back to going the way that we've always done things attitude if we see more and more companies taking this approach?
Yes and no. My personal opinion is I think it's terrible. If an employer has so little trust in an employee that they won't let you work from home because, let's say, you have other responsibilities at home, like maybe you've got some caring opportunities that you need to do, or some responsibilities like that, or you're physically not able to be in the office. Maybe you have some kind of disability or something, and then you want to make sure that someone's in the office every day so that you can see them face to face. There is a benefit to face-to-face interaction, but it's not always possible. And on the flip side, there are even people out there in the world who are advertising the possibility to work flexibly and be a digital nomad. So I was in Costa Rica last spring, and there are hundreds of Americans who are digital nomads in Costa Rica, in the Virgin Islands. A friend of mine just literally moved from the US to Albania because they got a 12-month-long visa for US people to go there and live and work. And what's the reason for that? Is that they want to bring people to enhance the economy, to turn the economy over a bit, to learn from them, to trade skills and things. So we actually would be doing a disservice going back to the old ways. And as for people rolling back DEI initiatives, personally, I think that's a terrible thing, because what happens when the three letters of DEI, diversity, equity, and inclusion, but it's really the diversity, to me, that I think they're all important, but diversity of thought, opinion, and ways of doing things, performing tasks or bringing new ideas. When you shut those things down, you limit that. And so personally, I think it's terrible. I know a lot of people are doing it, but it's not the 1800s. We don't live in Victorian England anymore. However many people would like to go back to the bad old ways, they're called the bad old ways for a reason. And going backwards, it will just be a detriment to everything that we've learned and developed so far. We can't go back to using a chalkboard and an easel. We use iPads, or we send telecommunications. We're not going back to that kind of thing. We use whiteboards where people can exchange ideas, and the whiteboards are cleanable. You don't even need a whiteboard anymore. You can just write on a wall with specialized paint, and then you can scrub it off and use it again. So we can't go back to the ways things were. What's next? Sending women back to the kitchen? I know some people would like that, but I'm not going there.
Eliana, thank you so much. I mean, that's a perfect note to end on there. Really appreciate you taking the time for your presentation today. It's always great to hear from you. So thank you so much.
Thank you so much, Laura, and good luck to the next recipient of the award. Enjoy the rest of your day.
Great. Thank you, everyone, for tuning in and to watch too. Please stay tuned. We've got our economics track coming up next. Our final speaker of the day before we go ahead and reveal our TCT Women 3D Printing Innovator Award finalists for 2025 is our most recent recipient of the award, Brigitte de Vet. Brigitte is the CEO of Materialise. She is an experienced business leader, having spent 2 decades across multiple industries, including 8 years leading Materialise's medical business. And when we were putting together today's event, I was really thinking back to Brigitte's acceptance speech at the TCT Awards last year, where you talked about how innovation is only meaningful if we manage to create impact and meaningful value, and how the challenge of really yesterday was about convincing people of AM's value, whereas today it's more about adoption and scaling AM cost effectively with quality too. So with that kind of ethos, I think, Brigitte, you are the perfect speaker to represent our economics track for today's event. So I will step aside and let Brigitte take over. Welcome.
Excellent. Thank you, Laura, and thank you for having me today. Yes, indeed, building on the topic of last year and the theme of last year, the road to success, in my eyes, needs to look a little different, where we need to think beyond technology. So let me explore that a little further. I think it is no doubt about the fact that our industry has been struggling in 2024, going through a lot of negativity for some time, in not seeing the adoption that we all thought we would have in additive over time. And in my eyes, I really think we do need to redefine what success looks like. Now, what do I mean with that? In the past, we brought new technology, and we're really proud of it. But to be frank, our customers don't really care about 3D printing technology as such. What they care about is the value that we create through additive. Take the example of Aerospace customers. An Aerospace customer that wants to build a wingtip for the largest all-electrical aircraft doesn't really care about whether that wingtip is done with additive or not. What they care about is that the wingtip is strong and lighter to enable what they want to do. Similarly, when you look at an industrial customer for a maritime cylinder head, it doesn't really matter whether that's 3D printed or not. What does matter is that that cylinder head is more energy efficient and is 60% lighter than what you could do with traditional technology. That's real value. Lastly, an example in the medical space, when we look at our personalized implants, the example of our hip implants, again, healthcare providers and patients really don't care about whether that implant is 3D printed. What they care about is the fact that that patient remains healthy and doesn't need to be intervened on again and doesn't need a second operation to place yet another implant. And that's what I mean with we need to redefine what success looks like. Success is a lot more than just bringing cool technology. Success needs to go beyond that, look at the value that we create. Back to the example of the hip implants that I mentioned, what is value is that the patient does not need another operation. And we know that with traditional implants, that 15 to 20% of the patients come back after revision surgery and need yet another implant. Whereas with a 3D printed implant, based on the data that we have collected on our Amaze implant, we know that there's only 2% of the patients that need to come back. Makes a huge difference. That's value that we create. That's what we need to focus on, because that's how we create adoption going forward. Now, if we want to redefine that path to success and look beyond technology, there's 2 things really that are going to be important. The first one is patience. I think we all know that, I mentioned it before, the adoption of additive has taken longer than many of us would have wanted, and a lot longer than some of us have predicted. Now, at Materialise, Fried, the founder of Materialise, has always said that 3D printing is a slow revolution, indicating that it does take time to adopt additive and create that value that I was talking about. And we can look at, numerous examples where that time was necessary. Take the fuel nozzle, the GE fuel nozzle that, is one of the outstanding examples we have of the value that additive can create in this application. It took 12 years to go from concept to first production. or at least stable process parameters to be able to produce. And it took yet another 10 years to get to large scale, where GE announced in 2024 an investment of 650 million into the engine that carries that fuel nozzle. So a long time to create that value. And yes, patience is needed. We see the same in our materialized technology. For example, when we look at personalized shoulder procedures, where we started in 2003, 3 years later, we hardly had treated 3,000 patients cumulatively throughout those 5 initial years. It took us yet another 10 years to get to 45,000 patients. And then over the last 2 years, we doubled that amount of patients that we touched. Suddenly seeing the scale, suddenly seeing that adoption, but it has taken us a long time. So yes, patience is absolutely needed. At least, in a lot of the cases where we see the value, until we get to that point of no return, where the value is so clear that suddenly we get that upscaling that we saw in the example that I mentioned for shoulder procedures, and then we see in the example of the fuel nozzle. Now, admittedly, sometimes we do have examples where the adoption goes faster. Think about the hearing aids. Within 500 days, 90% of the hearing aids were shifted to 3D printing because the value was so clear. So adoption can go fast, possibly faster in non-regulated industries or less regulated industries than in the regulated industries like aerospace and medical that I talked about. Now, obviously, what doesn't help to accelerate that adoption these days is when we look back over the last 10, 15 years, admittedly, technology kept advancing and progressing for the better. But that didn't create the stability for companies to say, I'm ready to invest large scale, because we kept on expecting better and newer technology, hindering that large scale adoption to a certain extent. Innovation and progress that was well needed and certainly has had its value, but that hasn't helped the acceleration of the adoption. Second complicating factor, of course, these days, certainly when we look at 2024, is the economic instability of a lot of companies in our sector. A lot of companies are struggling. We see a lot of redundancy rounds, and it doesn't help to create the confidence that if I buy a machine today or invest in additive and I scale in additive, that my supplier is actually still going to be around tomorrow. And even if the supplier is still around, if my supplier is going through huge redundancy rounds, reducing the workforce by 25 or even 40%, as we see some companies do these days, am I really certain that I'll get the service that I need on my machines if I want to scale up large time, big time? So that puts question marks, that hinders the large scale adoption. So we do need patience. It's a slow revolution. It's going to remain a slow revolution. And we do need companies with the longer term vision and the capital strength to sustain the adoption and keep on being with our customers and stay in the industry as a stable factor. Now, I'm well placed to count myself lucky to say that Materialise has been one of these stable partners and will be one of these stable partners, but it's a factor to take into account when we think about how to accelerate adoption in the industry to really benefit from the technology to its fullest. Now, the second element we need to take into account is what we call power to the people. Let me explain. What we'll have to do and continue to do is take the hurdles of adoption of AM away. Back to my acceptance speech last week, that was the big topic of, that I conveyed to the audience, that there's still a lot of hurdles that people are facing when they want to adopt or scale additive. And we need to continue to do our best to take those hurdles away. We need to focus on creating the value and take these hurdles away. Now, what does that mean concretely? One of the things we definitely can do is continue to automate, make it simpler, easier, and faster to adopt and scale additive. Take manual steps away. make our tools or provide tools that can be used by a broader population, at our customers, and not just by the highly skilled workforce, by automating steps. Certainly in automation, artificial intelligence has a big role to play. AI has been talked about a lot in the last couple of months and years, and rightly so. The potential is huge to help us in that adoption and taking these hurdles away. Now, at the same time, I think AI, or the power of AI really hinges on having the data, hinges on having the right use cases, and we all need to be careful that we don't overpromise on the potential of AI when it comes to additive. We've overpromised the potential of additive potentially in the past. Let's not make the same mistake here. Let's stay vigilant and make sure that we deliver something that is robust and keeps the high standards that we need to adopt AM in some of the segments where the value add is high, certainly in the regulated segments. Now, as I said, to do anything with artificial intelligence, at the basis, you need data. And that brings me to my next point. We need big data across the whole value chain, across the whole workflow. And to be able to have that data, to then leverage AI, to then automate, we need collaboration as industry partners and with our customers. We need to work together to make sure that we have the data throughout the process, to be able to use data at the back end of the process to inject in the front end of the process the next time I'm running an additive process. So using quality data of the parts that come out of my machine to inject that, to learn about how do I need to design the part, but also build support structures and run the build prep process to make better parts, more robust parts in the future. And that industry-wide collaboration is something that, again, we've talked about in 2024. We've launched a new initiative as an industry, the Leading Minds Initiative, where leading partners of the industry come together to talk exactly about this, make sure that we create interconnectivity, we create compatibility to make it easier for our customers to adopt and scale additive, connect the data points throughout the process to accelerate the adoption, to automate, use AI and the power of AI in order to do that. Very important initiative. Now, at the same time, as an industry, we also need to make sure that we enable our customers to do what they know best to do. They know their applications. We know the technology. We know what the technology can do, but our customers know best what they need to optimize their workflows and to adopt and scale additive further, which is why I'm a strong believer that we as an industry need to give our customers the right tools. And that means that we embrace openness. We open up our tools and technology for our customers to use them in the best way possible for their specific applications. Now, what do I mean with this openness? I'm talking about openness around process parameters at the machines. I'm talking about openness in terms of materials and making materials accessible for customers with whatever machine technology we're talking about. And I'm also talking about opening software tools and the power of the algorithms that have been built over the last 3 or 4 decades and make those available to our customers. That's the bold decision that we as Materialise have taken in 2024 to make our algorithm base available through the means of our SDKs, where for build preparation steps, customers can now tap into that fundamental base that has been built to build their workflows and script their workflows for their applications in the way that brings out the best performance, the highest efficiency, in those workflows. And that's what I call creating openness, embracing openness, really making sure that customers have access to the tools that they need to accelerate that adoption. All of this goes a lot further than just bringing the next new cool technology. So it's all about making sure that we don't talk about the technology, but the applications we empower and the value we create for those applications. Making sure that we have the patience to demonstrate that value and get to the point of no return where the adoption is so clear because of the value that is created. And making sure that while doing that, we continue to take away the hurdles of adoption so that we can accelerate and give additive technology the place it deserves in the toolbox of manufacturing companies as they power their applications and create products with value. So that's the road to success. It's a lot more than just technology.
Thank you so much, Brigitte, for that. There were so many key takeaways there and so much that I really just want to ask you about in this last 5 minutes. You talked about patience and you just touched on it again at the very end. You mentioned the 12-year journey it took with the LEAP fuel nozzle and creating value with that product, and it becoming this kind of poster application for additive manufacturing. But it took a very, very long time, and I think that's something we do need to accept about this technology. It's not just an overnight success story. And we've seen a lot more attention put on this industry in the last 5 years. Of people get very excited, lots of investments. We've seen SPACs, investments, good or bad. Sometimes it's worked, sometimes it hasn't. How do you think we sort of better position additive manufacturing, maybe to those outside of the industry, to ensure that investors, potential users do understand its true value and don't maybe become disenfranchised when it isn't really the quick revolution that was perhaps promised about 10 years ago?
I think the best as an industry we can do is focus on continuing to create that value and talk about the value, but then talk about the value in a realistic way, and use the examples that we know to create some sense of realism as to how long it can take, without creating negativity, because I'm absolutely not saying that needs to turn into negativity. It's just realism that we need, because the value is there, and there's a lot of use cases we already have. And when we see the R&D investments that have been done over the last decade, these R&D investments will turn into positive use cases that will scale. So the promise certainly is there, but we need to keep it realistic. And using the examples and continuing to focus on creating that value and showcasing that value, I think is the best thing we can do as an industry.
And I think there is a real balance to strike there. You talked about AI and how we need to be cautious that we don't kind of repeat the cycle of hype we've had in additive manufacturing and do it again with artificial intelligence. But, we want to be excited about these innovations and, we should be chasing after these things. But I think it's about balancing that with the reality and where it does add value, crucially.
Absolutely. And I think the best way to balance it is always talk about what we already have achieved and the use cases that are there, because those are real. And that's perfectly fine to talk about it. And we should be proud of them. But let's talk about what's real. Let's not build, castles, dream castles that nobody will ever achieve.
And this is the economics track. And I think that additive economics is such an interesting topic because there are so many ways to prescribe value to additive manufacturing, additive manufactured parts. It's not always as simple as comparing this is how much it was to CNC, comparing this is how much it was to 3D print. There's lots of ways to find value between that end-to-end process. For example, one of AM's biggest benefits continues to be its ability to get products to market much faster. It could also be tooling, customization, all these other things. Is it sometimes a challenge to get maybe newcomers to look at the bigger picture of how we define additive value?
It's a challenge and it's not. You said it very well, Laura. The value can be in a lot of very different things. And that's the easy part about it, because you can always find an example of value that has been created that suits a certain outsider of the industry because of his or her interest. At the same time, that's also the challenge, because it's not just one way of looking at that value, because it's fragmented. And we can't say just simply with additive we create value this and that way, and these are the metrics we can look at. So it's a lot more complex, but it also makes it, as I said, easier in a way, because there is so many different examples and ways we can create value. So people externally to the industry we can always find, a good example as to what additive can actually achieve.
Mm-hmm. And I'd like to just finish by talking about one of the topics that this industry talks about a lot, but it's something that Materialise has historically been very, very good at. You've touched on it in this presentation today. There's always a lot of good intentions and shared ideas around striking partnerships in order to advance the AM industry together, collaboration. How do you think this industry is really doing in terms of words versus action when it comes to collaboration? You mentioned the Lead in Minds initiative that was launched a few months ago. So how well do you think we're doing?
Honest opinion, I think there's room for improvement. The reason why we launched the initiative as well. I think there's been a lot of talk around collaboration. There's a lot of talk, or has been a lot of talk, certainly in 2024, about consolidation and maybe a lot more action on that side. But true collaboration beyond consolidation, I think we're still at a point where we focus far too much on how can everybody get a piece of the cake that we have today, rather than how can we all together create a larger cake so that we can all benefit, and the part that we have grows automatically. So yes, there's room for improvement. Now that's up to everybody, including Materialise, to take action here, which is why we've taken the initiative in 2024 and will continue to do so going forward.
Great. Well, thank you so much, Brigitte. I think that's a great message to end on there, and kind of an open call to everybody listening today to do more together and to be a bit more open to. So thank you so much for today's presentation.
Thank you, Lara. It was a pleasure to be here.
And to everybody watching at home, please stay tuned. Coming up next will be our final panel session where we reveal all of our finalists for the 2025 award. So stay tuned. I'll see you in a moment. Okay, welcome to our final session of the day, our panel to reveal the finalists for the 2025 TCT Women 3D Printing Innovator Award, sponsored by EOS. You've just heard talks from each of our 4 previous award recipients, and I'm very much looking forward to putting some questions to this year's group of innovators and learning about each of their contributions to the 3D printing industry. Our finalists were nominated by their peers and shortlisted by a panel from TCT and Women 3D Printing, but the winner will be decided by a public vote, which will go live right after this panel session. So be sure to stick around, get voting, get sharing. The winner will be announced at the TCT Awards, which happens on the 4th of June here in the UK. So I really just want to get into it. I am pleased to welcome this year's TCT Women 3D Printing Innovator Award finalists. Hello, everybody.
Hello.
Hello. Hello. So we have Sophie Magnuson, Manufacturing Engineer at Okada Technology, Clara Ramachi, Head of Product Management, 3D Printing and Digital Manufacturing at HB, Ainayan San, Head of Technology and Operations at Cossum Medical Group, Katie Weimar, CEO and Co-Founder at Genesis Tissue, and Johnny Messer, Global Additive Manufacturing Lead at Ford Motor Company. Thank you so much, everybody, for joining us today. I am so looking forward to getting into this with you all. And congratulations on being a finalist this year.
Thank you. It's a pleasure to be here.
Thank you for having us.
And I was just saying before we joined, what I really love about reading through all of the nominations and hosting this panel session every year is just the breadth of AM industry knowledge that we have on one call. We're very fortunate to be able to tap into this every year with this shortlist. So very much looking forward to getting into it. We do have such a wide knowledge base and roles on today's call. And at TCT, we've really been making a conscious effort recently to kind of highlight the different pathways into the additive manufacturing industry, because there are so many different ways of getting into additive. So I want to ask each of you to, first of all, just introduce yourself and your role in the industry and really tell us what was your pathway into additive. Sophie, I think we'll start with you first.
Hello, everyone. My name is Sophie Magnusson, and I work at Okada Technology in Sweden. And I am a manufacturing engineer. And Okada works with an automatic retrieval system. So I particularly work with the 600 bot, which is the next generation of robots. So this robot is 3D printed in contrast to the previous ones, and this robot basically retrieves groceries that are packed and distributed to customers. I started as a mechanical engineer with my studies, and I worked as that for some time. And then, as we all know, COVID came and changed the world, and I lost my job. And I wanted to sort of widen my horizons and add something to my mechanical engineer diploma. And I had been quite intrigued by 3D printing and what it could do. So I actually started studying 3D printing specifically. I also have a love for making Halloween costumes. So I think that added to the interest in 3D printing.
Great, thanks so much. Janae, how about you?
So yeah, I'm Janae Messer. I am employed at Ford Motor Company. I've been here for about 28 years. I now run an AM lab here at the Sharonville transmission plant, and we make spare parts and end-of-arm tooling and stuff for our plant.
And how did you first get in touch with additive manufacturing?
So we actually had a problem out on the floor. I used to be a maintenance team leader, and on the floor we had a problem that we came into every single day, and we tried numerous other solutions to try to fix this problem. And we ended up begging our boss to let us buy a 3D printer. We said, we're pretty sure we can fix this with this. So he sent us into this room and said, you guys figure it out. I don't want anybody to know what you're doing. Well, ended up, it was a win, because we were able to replicate our solution that we fixed on one line across 9 other lines. And it is, we had no clue what we were getting into, but it has definitely grown and expanded beyond our belief.
Wow, what a great case study for additive manufacturing there. And we'll keep going around clockwise. So what about you?
Hi, I am Yeong San. I am head of technology and operations at Cosm Medical, where I've been leading product development for the last 5.5 years. Our first product is a personalized pessary for prolapse management. So prolapse, for those of you who are not aware, it's when organs like bladder, uterus, and rectum shift out of place due to weakened support structures. It's more common than people realize. It can happen to, the stats show 1 in 2 women as we age can be affected by this, and it can be incredibly painful. So at Cosm, we are transforming how prolapse is managed. We've developed first digitized gynecology device that is custom fit for each woman body using 3D printing. So we're using advanced software and AI together with additive manufacturing to revolutionize women's health with these personalized devices that can restore comfort and quality of life for women who previously had no effective solutions.
Wow, and what was your sort of journey into this industry then, and relationship with this technology?
Sure, yes. I was one of the first employees to start at Cosm Medical. And it's been very, any medical device road is at least 3 to 5 years. So we've been at that for that long. It's about demonstrating safety and efficacy and coming up to ensure that we can meet stringent regulatory requirements. And 3D printing material and biocompatibility is a big challenge in this industry for medical devices. So we've gone through FDA application. We were successfully approved. Our device was first in our device category to be approved in over 5 years. So we're very proud of that achievement, and we look forward to commercializing and launching our product.
Great, thank you. Katie, what about you?
Yeah, thanks, Laura, for having us today, and congrats to all the other panelists. It's quite an honor to be a part of this distinguished group. But maybe I'll take your question in reverse order, if I may. So again, my name is Katie Weimer, and really my path into 3D printing, not to age myself, but it started about 20 years ago when I was looking for my first job out of college. So like it sounds like a few of the others here, I'm a mechanical engineer by education, and I had done some master's degree in computational biomechanics, where I did medical image processing to develop a personalized computational model of the knee. So I did this like looking at CT scans and tracing the edges to try to turn that 2D medical imaging data into a mesh file, right, into CAD that I could do some biomechanics on. And I had graduated. It was a fantastic beginning to my career. But then I was Googling jobs and was Googling like computational modeling in Colorado. And I found this startup that was at the forefront of 3D printing in healthcare called Medical Modeling. And that was nearly 20 years ago. And so I've spent 20 years very focused on 3D printing in healthcare. Truly feel very blessed and fortunate to have been a part of that segment of AM as it was really emerging in our industry. So did things like, running old SLA printers and doing image processing and anatomical models. Was very fortunate to be a part of the really the forefront of personalization in things like virtual surgical planning and personalized implants. Had an opportunity to run operations, just sort of mass producing, titanium, medical devices, implants, and also doing, cutting guides and personalization. And then was very fortunate in sort of the second half of my career to get to move over to Chuck Hull's advanced R&D team to focus on bioprinting and regenerative medicine. So it's really been a phenomenal journey. And I'll tell you a little more in a little bit about kind of the most recent job I'm doing now, but really focused on tissue engineering and how can we use additive manufacturing for what I think is really the next revolution in healthcare. So yeah, again, a pleasure to be here amongst this fantastic group of women.
Great, thank you. And Clara, what about you? Tell us about your journey into additive and where you are now.
Yeah, sure. So I'm going to use the same order as Katie. I'm going to start from the beginning. I think my journey into additive, as well as many of us in this panel, was kind of random. 10 years ago, I was studying in San Diego in the US. My background was in industrial engineering, but then I wanted to do an MBA. So I was there, and in the university, they had a service where we could go as students and print a file. And to me, that was the first I ever heard about 3D printing. So I wanted to give it a try. And don't ask me why, but I wanted to print a lion. So I submitted the request, and a week after I went, and the print had failed. So my first ever 3D printed part was actually half a lion, which I still have. And that was it. And when I finished my stay in the US, just before coming back to Barcelona, that was like the end of university and all that. So it needs to get real. You need to get a job. And I was never one of those people that have it very clear what I wanted to do. So I went to San Francisco for like a few days, and I started talking to extremely random people from like VC, people from corporates, entrepreneurs, just to understand, like to try to understand what I really wanted to do. And the outcome from that trip was I wanted to work in a technology company. It had to be like a mixed role between technical and business, and it had to be a product that wasn't created. That was like my summary of the trip. I went back to Barcelona, and I had to have a surgery. So I was recovering at home. And the reason I am in 3D printing is because one day my mother came and she was super pushy. You need to get a job. And I'm like, yeah, but I am recovering from a surgery. And she was so pushy that I started looking for jobs. And I found one in Barcelona that was HP was getting into 3D printing. And that was in early of 2016. So we didn't even have a product. It was like the beginning of everything. And it checked all of these 3 boxes. So I applied, and 2 weeks after I started to work for HP. It's funny because the week I joined was exactly the week that we launched the first 3D printer. So I was able to kind of live throughout all the journey, and the rest is history. I got randomly into this industry, but now it's impossible to leave because it's amazing. So.
Great, I love that. And you are right, there's so many sort of random stories that we get of pathways into additive manufacturing, and that really just encapsulates the sort of journeys I hear so many people going on. So I want to ask you all some questions now about each of your individual experiences in the industry, because as I mentioned at the start, each of you are nominated by industry peers, and we get this really nice little spreadsheet where we get some great compliments about each of you and all the amazing work that you've done. So without embarrassing anybody, I'm going to use some of that really to shape this next set of questions, because I'd like to focus in on a few reasons and projects that were highlighted in each of your submissions. So we'll start with you first. You worked on, as you mentioned before, you worked on the clearance of the first digitized gynecological device leveraging 3D printing to make millions of variations for women. You spoke about that process and how long it can take to get something like that qualified and onto the market. So I want to kind of ask you a little bit about that, but also we know that medical products aimed specifically at women's health do typically tend to be a bit more of an underserved market. And I wonder if you think 3D printing maybe has a unique role to play in accelerating that development of products that are focused on women's healthcare devices in particular.
Yes, absolutely. Regarding women's health, 3D printing made our product possible because we can make complex structures that is customizable. So up till now, we take this one-size-fit-all approach that overlooks our unique body diversity. What makes it even more impactful is the feedback we receive from our customers, many of whom have struggled for years without relief. We hear customer feedback like, my pastry is magical, because for the first time they find a solution that truly fits, providing comfort and restoring their quality of life. So I believe our platform empowers women, giving them back control over their bodies and their life. And additive manufacturing isn't just a technology, but is a transformative tool delivering dignity and personalized care in women's health.
Yeah, great. Thanks so much. And Clara, you've just spoken then about this kind of random journey that you had into 3D printing, but really because of when you started at HP almost 9 years ago, you've seen a technology go from really just the beginning to being adopted by some huge customers around the world, and you've seen this technology progress. I wonder if there's any kind of key learnings that you can share, because we do see new additive technologies coming onto the market all the time. But are there any key things you can share about managing a technology or a product and delivering something that the industry really wants? And then the second part of that is, I also understand that you spent 2 years as a technical consultant at HP. So I'm also interested to know, within the time that you've been there, how have conversations around 3D printing changed as the acceptance of the technology has?
Yeah, there's a lot to say to that question, because it's been like 8 years of learning, and the first team that I was part of was focused. We had just launched the technology, and of course, HP was entering into the market, and the sales team were basically selling to prototyping and all that. But at that time, there was a team that was focused on figuring out final part production applications. And again, randomly, I started at that team, but it was amazing to really, because we were kind of in the complex projects, the ones that were pushing the limits. I mean, we have now Sophie from Ocado. That was the type of projects that we were dreaming about at the beginning, like someone that would really understand design for additive manufacturing, that wanted to do it at scale. But at that time, those were the status of the industry was not that, no? And what have we learned is that we tend to focus a lot on the technology. And now that I'm leading the product management team, it's very easy to focus on the technology, on making it faster, making it cheaper, bigger. That's very technology driven. But the reality of all these years is that we underestimate what it takes to really adopt. No, you go to customers and you have to really understand what are the costs associated to requalifying to change the material. You have to really understand what's the level of education that needs to be built at the customer side. Learn how to redesign, how to pack parts, how to drive behavior inside a company. So adoption is something that has been, or what it really takes to adopt, it's something that we have underestimated for a long time. We have focused just on the technological part and focusing more on the adoption, what it takes to help companies like Ford, like Ocado, everyone. The change that they need to drive inside their companies, it's something that from our side we need to support a lot more. So that's what I would say that the key learning, being this paranoid about why people adopted, and those that adopted, how they did it, those that couldn't, why not, and linking it to your second question. When I was on the technical side helping customers adopt technology in doing application development and so on, we did one day we did an analysis with this framework of the crossing the chasm, no, of the innovators, the early majority, all of this. There's a calculation you can do, and we did it by application. And there's different things that you basically rank, and the outcome of that analysis was that most of the applications were not close to the crossing the chasm point. And the reason why was because the whole product was not completed. There was not an end-to-end solution. Back in 2017, 2018, it was about, with customers, it was about making it work. The change now is when you talk to customers, is about making it work at scale. Before we were talking about how to post-process this, how to figure out the digital workflow. There were bits and pieces, but no one had really put it together. Now, if you look at orthotics and prosthetics, the whole end-to-end solution is figured out. So this is one of the key differences that I see between the conversations before and now. And maybe the second and last thing is, before you had to do a lot of education on what is the right application to be printed. I remember we were working with BMW and Dominic. He always said, think before you 3D print. There was a lot of this that we had to do at the beginning, because people would come with whatever ideas, and you knew that was not the right application, and it would just generate frustration at the customer side and would delay adoption for several years if it's not the right application. Now, the market still needs to be educated, but there is a lot more knowledge. So the applications that we receive initially from customers already, they are already well thought of, and that accelerates the conversation way more.
Yeah, think before you print. I think that's a good mantra to live by. Janae, I'm going to ask you next. I'm going to keep going in alphabetical order. So you were described in your nomination as someone with a constant positive, never say no to any additive possibilities attitude. So firstly, I want to ask you about that and whether you believe that's the sort of AM mindset that we really all should be having to encourage adoption. And then second, your nominator also described you and your lab as really being the benchmark within all of Ford Motor Company. So we know Ford has been using additive for a very long time, but I wonder if you can give us any sort of insight into what it's like introducing a new technology or a new way of doing things into such a huge established organization like Ford.
So the never say no. So like when a job comes into our office or we're out looking at different things, I don't ever let anybody immediately say no, because like, oh, well, that's too big, or it's because it's made out of this special steel, or it has a really high tolerance, or, so I make everybody go out and we do our due diligence on a job before we could ever say no. We go out, we see the application, we see how it works. We find out the usage of that part. We find out the cost of that part. We find out if there's any problems with the existing design. Because you're always, whenever you're out there working on something. They're like, if they had just moved this over 5 millimeters, we would never have this interference again and the job wouldn't go down. So now that's in our control. We can make all those things happen. So once we go out and investigate it, and we have all kinds of experience here in our lab because we have all skilled trades. They know all the problems that they've seen and everything. So we'll go out and then we'll come back and make an educated choice. Are we going to be the most cost effective? Are we going to be, or can we meet the usage and everything like that? So we'll go through and we'll check that out. And sometimes we'll decide that we shouldn't do this job, or we'll decide that maybe we'll work with our tool room. We'll use either technology, that whatever's the most efficient at the end of the day and keeps parts in-house that we're making now, and it improves our processes here at the line. So we do ultimately say no sometimes, just based on whether or not it was the right choice for additive. So, and then the second part of your question, benchmarking at Ford. So as you said, Ford's been in additive before I even knew it existed. I had, like I said, 8 years ago is when we jumped in the arena and started playing, and we started making the parts for our conveyor line, and then that was a success. And then people started coming to us and they're like, hey, what about this? What about this? And then eventually we're starting to make spare parts for other departments in the plant. And then we had executives come to the plant and they're like, what the heck are these people doing? So they come in there, they're checking out what we're doing, and they're really super excited about it. And since our inception in 2017, we've saved Ford $8 million in spare parts. And most of the time we've improved it. We've made the parts better than what they were originally. And so, so it's always been super exciting for us to keep moving forward and seeing how everything's changing. And since we started that, I've now been made the Innovations Global AM lead. I'm now responsible for scaling and reproducing labs throughout Ford. With that, we're coming up with different procedures and processes and testing and teaching people. We refer to it as how to fish. We teach them how to go out and find parts, find out what's a good fit for AM, and then we help them build their business case to purchase the machines and get their ROI on them.
Wow, that's amazing. And to see how much it's grown in that time. And, as you said, it's not the right fit for everything, but once that seed is planted, it really sparks ideas throughout the business. So that's really amazing to hear those kinds of numbers. And Katie, continuing in alphabetical order, I'm going to go to you next. So you already spoke about your time in this industry and, most recently leading the 3D bioprinting efforts at 3D Systems, which still very much feels like this kind of next frontier of additive manufacturing. If I could say one bit that still feels a little bit sort of sci-fi and additive manufacturing, really. So I wonder if you can maybe give us some insight into the developments that are already being made there, maybe some things that might surprise some viewers and listeners here today. And second, I know that you've recently spun out your own company. So I wonder at this stage how much you can tell us about what you're doing there.
Yeah, thanks. Really excited about this field of bioprinting as sort of what I think is the next frontier, right, in our industry. It feels a lot today in bioprinting like we were 20 years ago in healthcare. And so just to kind of maybe educate some folks that aren't as familiar with this on kind of where the industry is at today. So first, I would say, although it is new for us in additive, there's really about 20 years of sort of fundamental research in tissue engineering that are supporting this, this new effort in bioprinting. And I think one thing that is unique about this opportunity versus others is that it's really a combination of three industries that have a play. One, the biotechnology industry is very involved in using bioprinting for tissue engineering and regenerative medicine. Then you have the medical device, sector that's very interested. And then lastly, we have our AM, right? So those of us in 3D printing. And so it's really this Venn diagram of three different industries that are coming together to support this effort. I think the general community would be very surprised in how much money is actually now feeding into this. I can speak, I live in the US, so I know, over the last few years, even our federal government around grant programs such as ARPA-H have put hundreds of millions of dollars into funding translational research around bioprinted tissues and organs. As well as you see these large partnerships between bioprinting companies and pharma around drug development and discovery and therapeutics. There's an enormous amount of money, enough that we will see a real push for translational opportunities. And I'd say the last thing that I think is really interesting about this sector is that it's very application focused, right? It's not as much about building the next 3D printer to release the next model. It's what technology can we use to get this application into humans? And so I think an application-focused industry is really what's going to drive this forward to adoption. So we are seeing some very basic bioprinted meshes and bone products that are sort of the basic of tissue engineering that are cleared and available on the market today. So we are seeing some, we're seeing standards being developed for how to standardize these types of developments, as well as, regulatory pathways that are being paved for the rest of the industry to follow. So obviously I'm a little bit bullish on this, so bullish that I'm happy to announce today on this, panel focused on innovation that, I've spun out a company called Genesis Tissue. And Genesis Tissue is a 3D bioprinting tissue company that designs and manufactures personalized regenerative tissue implants for humans, starting with breast. So really the goal of this is, and it's sort of my personal mantra, I think, for the second half of my career is to move away from implanting industrial materials into humans, right? So you look at sort of the history of surgery and implants, and it's like taking the best industrial material like silicone or like titanium, and that's what we use, right? But I think we're at a point with bioprinting and regenerative medicine that we can do better and start to really replace like with like. And so that, what that means is a new generation of materials and applications that once implanted actually regenerate and become self. And so again, really excited to be able to announce the formation of Genesis Tissue. It's the first time I'm talking about it publicly here today. Like I said, I'm a little bit bullish on the bioprinting and regenerative medicine opportunity. But yeah, I think it really will be an incredibly impactful advancement in healthcare.
Yeah, congratulations. It's super exciting. And thank you so much for telling us about it today.
Yeah.
And Sophie, on to you. During your nomination, you were described as someone who has been instrumental in advancing additive manufacturing at Ocado, and particularly on the 600S robot that you mentioned before, which if any viewers today, listeners, haven't actually seen it, make sure you check it out, because it's a very cool looking robot. So Sophie, can you first tell us a bit more about the work that you did in additive for this particular product and the impact it's had at Ocado? And secondly, I understand that this was developed very much with this additive mindset. Is that something that's being carried through and leveraged for other projects at Ocado at the moment?
Yeah, the 600s bot, it is based on the idea of having like a lightweight structure. So a lightweight bot and a lightweight grid, and then you can also have smaller motors to drive the bot because it is lighter, it needs less energy. So my contribution to this has been in developing the ways we take out topology optimized parts. By using top-opted parts, we can drive down weight by up to 70%. And by optimizing this process, we can also make the volume of the parts smaller, and this also helps with the 3D printing of the parts, because if you have a smaller part, then it goes faster to print, and we use the MGF technology from HP, so we print a lot of parts in one bucket. It's a powder bed fusion technology, so it's a bucket full of powder that we fuse. So with less volume, you have a better heat distribution in the bucket. So driving down the volume of the parts will help how they turn out, the dimensional qualities and the technical qualities of it. And also we try to top up like the majority of the biggest parts in our bot to sort of make these implementations, because our bots, the 3D printed parts, they vary a lot in size, and this also like making it the nest a bit more homogeneous. It helps with the 3D printing. So this drives down cost, and you can sort of nest more parts in one bucket. So it also drives down time. Further, I've also been a part of optimizing our product for post-processing. For example, you have to nest a part in a specific orientation in the chamber for it to come out in the best way. If you, for example, nest something with a pocket facing down, then heat will go up and you might get some fused powder that you don't want to. So sort of designing out these heat pockets to avoid thermal bleed, which is it is called that. So this helps with assemblability of the bot, because otherwise you might have to remove these fused powder and do some more manual labor with post-processing. So yeah, making the bot easier to assemble and making the parts of it smaller, but like still meeting our technicalities. And also like we are in the process of starting to scale up and do some industrial printing. So also like driving that work and putting up standards on how we should produce our robot.
Yeah, and there's that word scale again that we've heard a few times already on the panel. That really is sort of this next level what we'll get into in additive. And as I say, it's a really impressive robot to look at. It's a really great showcase of all the benefits of additive manufacturing in one solution. I do want to talk a little bit now about one of my favourite topics, industry challenges. And I know we've got a few little bits of crossover on the call today. So I want to start talking about healthcare and medical. So I'll start with you first. So I wondered if each of you can talk about what's the biggest challenge facing your specific field right now, whether that's really an additive specific technology challenge, or maybe even something that you think is just a wider challenge in your industry and you think additive manufacturing is a great opportunity to help solve it. And so if I go to you first.
Sure, yes. As you know, healthcare is inherently a risk-averse industry. So introducing these highly customized solutions, as Katie already spoke about, it requires a shift that we are building new standards and procedures, but it also requires adoption that Clara mentioned, both from supply chain and users, our clinician mindsets and clinical workflows. Over the last year, we've been really trying to solve those issues at COSM, but AM can be a solution to that. We need to bridge the gap between R&D, regulatory, and production while reassuring absolute patient safety and device efficacy. It gives us a unique ability to rapidly prototype and incorporate clinical feedback into our product design so that we could do continuous improvement to have better patient outcomes. So I am very optimistic that, together as a community, we can solve these challenges.
Yeah, absolutely. And Katie, what about you in the same sort of healthcare field? What kind of challenges are you seeing? Are you seeing sort of similar ones that you think additive can help address?
Yeah, I think specifically, I'll just kind of speak from the bioprinting perspective. Again, I think there's very clear application opportunities here. So I don't think it's, we're a hammer looking for a nail, right? Like there are very clear use cases that bioprinted and regenerative tissue or organ constructs will make a remarkable difference in healthcare. I think the difference in this type of field versus what we're used to in traditional AM, as was already stated, it's obviously highly regulated, right? But the difference of a regenerative implantable tissue or organ, it takes an enormous amount of time, a decade or more to develop a product that gets implanted with a novel material. And it takes tens of millions, if not hundreds of millions of dollars. So the investment to get there, I think, is very different. That being said, the reward on the other end, again, it's a pretty straightforward business case to put together. But I think the challenge we have in bioprinting tissues and organs is just, a different type of commitment from a time and money perspective to get this done. It makes the journey, it's a tall mountain to climb, but it makes the journey very exciting and very worthwhile. But that's why we have to collaborate with pharma, biotech, med device, right, that have the funding that can actually support getting these novel implants and tissues and organs to market. So very worthwhile cause, but I think very different from an investment time perspective than the rest of the additive manufacturing community is used to.
Janae, what about you from an automotive perspective?
I think the biggest challenges we face coming up is just like, we're still relatively, I use the word young, as far as what we're using additive for. So there's a lot of acceptance and a cultural change that we have to overcome here at the plants, and containing people's excitement also. Because like you've got these new labs coming on and they're like, oh my gosh, I'm going to print everything. And you're like, just because you can doesn't mean you should, So we're trying to slow them down, but not stifle their creativity or enthusiasm. But we have to make sure everybody's following and adhering to procedures and standards that we've set up that has been proven successes here in our lab. So that's probably the biggest challenges we face.
Okay, and Sophie and Clara, we've got kind of an interesting perspective here because, Clara, you're from the actual, machine perspective, and Sophie, you are the user of HB's technology. So what kind of challenges or, I guess opportunities as well do you see additive manufacturing helping to address or challenges in your industry? I think, Sophie, I'll go to you first.
I think for my company right now, the biggest challenge is industrializing AM. It is still like a pretty young manufacturing process, and there aren't like the best practices aren't really out there. So we're just setting that up right now. So it's the challenge we are facing right now and working on. I think the other one is maybe it was already mentioned, but like when to actually choose AM as a manufacturing technique, because sometimes it isn't like the best way to go, even though it's super exciting and super fun. But sometimes you maybe have to take a step back.
Yeah, I certainly think that's always something we can all worth reminding ourselves of every now and again. And Clara, what about you finally? Any industry challenges?
Building on top of what Sophie was saying, we see two challenges, and they are in both in the two extremes. If we think about what Sophie and Okado are trying to do, they are on the far right, like trying to industrialize and do mass manufacturing with 3D printing. There are a set of challenges that come from that, and that's dimensional capability. We have to get better at it. We have to get better at repeatability. All of these are challenges that all machine manufacturers, we have to keep working on this if we want to scale the technology. We are all actively working on it, but we have to continue to make the technology better, to make it more cost effective. So there's a lot that we are putting a lot of effort on actually reducing the cost per part if we really want more people to adopt at scale. So that's on one side. Then on the other, on the more like far left side is what I was mentioning before. It's how to drive adoption with the current market scenario and so on, the interest rates that are in the market, the investments from all sides are a lot more challenging. So how do we continue to drive adoption with people that has not adopted yet, considering the current economic situation in all places? No, those are the kind of the two biggest areas of challenges that we see.
Okay, great. And it looks like I've only got time for one more question with you all. Even though I could stay talking for about 2 hours on this panel session. So one last kind of final thought I want to ask everybody to leave the audience with today is, it has been a challenging few years for the additive manufacturing space, but I'd really like to end on asking each of you, what's keeping you motivated? What's keeping you optimistic about going to work in this industry every day? I think I'll start from the top and go around again. So Sophie, what about you?
Well, I think that there is still so much left to discover with AM, and for it to really find its place, like as a manufacturing technique. I also think that there's a lot of left to discover within hybrid manufacturing. So I'm very excited to see that being used more to like take advantage of the free form that is AM, but the precision with traditional manufacturing techniques. Yeah, and to see what AI brings to the table.
Great. Janae, what about you?
So I think what keeps me excited and motivated about all this, like we have so many new people coming to our lab to tour it and check it out, to see what we're doing, and then to start them off in their own lab and get to hear about all their success stories. And we started a community outreach program to where we go to high schools and we actually introduce them to like what we refer to as the spark, what got us started on our AM journey. And to see these students and see their like eyes light up, they're like, holy crap, Ford's here and look what they're doing. And just everything that their teachers are teaching them and saying, this is real, keep applying yourself. And then we come in and we show them these different things, show them the cost savings. And so I'm always excited to see each person come in and each person that we make happy and them sharing their experience about us and with us and promoting us to other people.
Great, thank you. A, what about you?
What keeps me motivated is the profound impact AM has on real lives, knowing that every part we make has a face and a story behind it. It democratizes innovation. It allows us to address niche medical needs that will never be fulfilled traditionally with, even with huge manufacturing investments. I'm also very inspired by this collaborative spirit we have within AM community when talking to different companies, collaborating. We are just very open to help. And I think I'm very happy to add all of you, us 5-6 here today, into that network. But despite industry challenges, there's sure belief that we're building a real future, layer by layer, tool by tool, process by process, material by material. So I'm very optimistic with the opportunity to innovate.
Absolutely. Katie, what about you?
Yeah, for me, it's really the hope and promise that bioprinting and regenerative medicine have on the future potential impact to improve healthcare and humanity, right? Whether that be, novel drugs developed using, organ on a chip type of constructs, or 3D printed functional organs that help solve the transplant crisis, or, in our case, regenerative tissue implants specifically for breast that regenerate over time and become self. I think that we're just at the beginning of this sector of additive. I think it could be a real bright spot in our industry and has an enormous amount of potential to impact humanity for better.
Definitely. And Clara, just to finish with you, final thoughts, optimism for the industry.
No pressure, huh? No, I would say the first thing is the people of this industry, because when we talk about critical success factors to drive adoption, we always say finding the right application, executive support, but then having a champion. And this champion profile, it has a certain personality, and you meet people in this industry and everyone is a champion. I didn't know the people in this call, so it's been a pleasure to get to know you all, because you all fit that exact profile, and you walk through the AM trade shows, and the industry is full of this type of people, and that's I don't think you can find that energy and that passion in several other industries. So that's, to me, the biggest thing. And even if the industry has gone through huge hype, and now we are a bit more in like this curve of adoption of new technologies, we are more in the figuring it out phase, but all the promise of 3D printing is still true. All the ability to create better products, more personalized, the supply chain, sustainability advantage, that's all still true. And now it's getting even more real. So that's making it more and more real is what actually motivates me the most to continue in this industry.
Great, thank you so much. And what a great note to end on. There's so much optimism and passion with this industry and for the people in this industry too. So thank you so much to each of you for taking the time to join us on this panel session today. And once again, congratulations on being a finalist for this year's award.
Thank you so much.
Thank you for having us.
Thank you.
So to everybody who's tuned in now, the public vote is now open. Very exciting. You can actually go and vote over at tctawards.com and save the date as well for the TCT Awards ceremony, which is happening on June 4th at the NCC in Birmingham, UK. Good luck, everybody. We'll see you on June 4th for the announcement. And thank you all for watching today. All of the presentations from earlier will be available on demand, as well as this panel session. You can rewatch at the same link that you joined at. This TCT Women 3D Printing Innovator Award Day was brought to you by the TCT Group and TCT Awards, alongside Women in 3D Printing and the TIPE 3D Printing Conference. Thank you to our TIPE partners, Nanyang Advanced Manufacturing, Bamboo Lab, SME, and to our award sponsor, EOS. So thank you very much again, and get voting, everybody.